Hi, everybody. I'm going to just get up and running really fast. All right. So my name's Kathy Simpson, and I am from San Francisco, where we are on the water, but it is, feel like I have to, since everybody's talking about how cold it is back where they are, it's 11 degrees there Celsius right now, so I am not used to this weather at all, but I'm loving it. And this is my first time to Split, and first time to Croatia, so I'm super excited. So I help run product management at GitHub, and I specialize in developer experience. And with developer experience, I have become really, really passionate about developer tools and about collaboration tools, code collaboration, how teams work together, etc. So I'm pretty excited to be able to share some stuff that I've learned recently about a topic that I could geek out on forever, which is how NASA actually works together. So I'm going to start off by telling you a story. So this is the moon, and I'm going to tell you a story about Apollo 11 when Neil Armstrong and Buzz Aldrin first landed on the moon. So when they first landed on it, they took the Apollo 11 into orbit around the moon, and they were the first people to touch down too. So that Apollo 11 shuttle was orbiting around the moon, and they loaded themselves up into the lunar module. That lunar module, its name was the Eagle. So they loaded up in the lunar module, and they detached it from Apollo 11, and they went and they navigated all the way back down to the moon, to what's called Tranquility Base, and that's where they first touched down. Now, as they were going, they were paying a lot of attention to the orbital controls and the pitch and the attitude and everything. They weren't paying quite as much attention to the gas tank. And so they actually almost ran out of gas, and they had to measure the amount of gas that they had left in the tank with a stopwatch. And so the team actually measuring that, they calculated that they landed on the moon with only 18 seconds left of gas of fuel in their gas tank. And if they had run out, they wouldn't have had enough, or if they had gone over if they had been 15 seconds away from running out of gas, they would have not been able to do what's called a powered liftoff back to Apollo 11. So they'd still be on the moon. But they landed, it was glorious. They got out of the lunar module, out of the Eagle, and walked around. And they were the first men to step foot on the moon. So NASA knew at that time that they were going to, in order to pull something like that off, they were going to have crazy collaboration protocols and a lot of trust in their own communication. So I'm going to talk a little bit today about what that was like, what it was like to communicate between what was happening in space and mission control back in Houston. So just to put ourselves there a little bit, I'm not going to ask you to participate too much, but I am going to ask you to imagine. I want you to imagine yourselves actually as part of mission control. And this is a photo of what mission control looked like back in the 60s. It looks a little bit different today, and you'll get to see what it looks like today. But this is the mission control room, and NASA loves their acronyms. I'm going to throw a bunch of them out for you. I'm going to try to explain them, though. So the acronym for this is MOCR, or the MOCR. And so in the front row of this, the seats, the desks that are the closest to those terminals you see in the back, the screens you see in the back, that's called the trench. And so I want these first couple rows to imagine that you are all in charge of the trench, and you're what we call flight controllers. And you're looking at FIDO, which is Flight Operation Dynamics. GUIDO, these guys in the middle, you're in charge of guidance operations. And then over here, you're boosters. And then I'm going to split the back room into two. So on one side, you're going to be thermal and attitude dynamics. And then on the other side, you're going to be orbital operations and subsystems. And I'm not forgetting about the balcony. You're all in charge of what we call the back room. I'll explain that in a minute. Okay, so now that I've kind of set the stage, as I'm going through this today, I want you to just kind of try to picture yourself communicating with your team, communicating with each other, and we are actually going to launch a rocket later on. So picture yourself there. This is actually the mission control computer. This is the IBM 790 mainframe, and this is where it was originally constructed. It was originally constructed in Washington, D.C., and then Cape Canaveral in Florida. And later on, when the Apollo missions kicked off, they actually reassembled it back in Houston at the Mission Control Center. So this this computer, this mainframe, when it was first constructed, and, well, there we go. So this mainframe, when it was first constructed, they actually fit it into a plywood box, and a big plywood box. And it was so hot in there, imagine you're in Florida, it's probably a little bit more humid in Florida than it is here. And so they had to use a chainsaw to cut out windows in the plywood, put air conditioning units in, and they actually had a canvas top on top. So that gives you a little bit of a sense of kind of how crude it was to build this mainframe and to build the box around it. But these guys would do whatever it took to build that mainframe to get their rockets and their space shuttles, their manned spacecraft into space. And this was one of those rockets. So this is actually the Apollo 11 rocket that I was talking about earlier. So Neil Armstrong and Buzz Aldrin are in that. And this is the launch, an animated GIF of the launch of it taking off to go to the moon. The computer that was used to launch this had 64 kilobytes of memory. That's 21 times smaller than this actual animated GIF. So we've come a long way, but you can imagine they were running out of memory all the time. They were dealing with computer issues all the time, and so in order to handle that, they had to be communicating and talking to each other. And the guy that was in charge of most of this during what's called the Gemini and Apollo missions, his name was Gene Kranz. He'll come back into the story later. He and I have been kind of working together on that rocket launch I'm going to tell you about in a minute. But Gene Kranz, he was very well known as a flight director who really commanded the room and gave a lot of leadership. And so when he started out, he was actually really nervous about not being able to give all that leadership. And so he went to his wife, Marta, and he asked her what a good symbol would be for him to take to the team, to really unite the team. And she said, you know, why don't I make you a vest? And then you can wear the vest and kind of everybody will kind of joke around about it, but they'll unite around it. And so she ended up making him a vest, and then from then on out, every single mission, Gene Kranz had a new vest made by his wife, and they became known as the Men in Vests. One of his most famous ones was for the Apollo 13 mission, and it was a white vest that became very iconic because of what happened on the Apollo 13 shuttle, and I'll tell you about that. So, looking back at this room, kind of a different angle on it, can you imagine the trust that this team had to have with each other? This team would have had to manage hundreds of applications and systems, all working pretty seamlessly and perfectly together, and NASA really didn't have a lot of the sophisticated APIs and automated eventing and Kubernetes and everything else that we have today. They had collaboration protocols that had to be spoken over the wire or in person. And they took that rocket, it's 300 feet tall, they took it from Florida at Cape Canaveral, 240,000 miles to land on the moon, and then they turned it around and took the astronauts back to Earth safely. So, can you imagine what that kind of coordination and communication looked like? I'm going to show you a little bit about it. So first, these are the flight controllers. These were the guys who are the most visible in the room, and if you've seen Apollo 13 or a lot of other like Hollywood space movies, you're going to see these guys kind of buzzing around. And they're in this image right now. They are coordinating how to fix the Apollo 13 oxygen tank explosion. So in Apollo 13, they were supposed to land on the moon, and when they were about halfway there, an oxygen tank on the Apollo 13 shuttle exploded, and it prevented them from actually landing on the moon. And so these guys had to figure out, back at Mission Control, how to fix the oxygen tank, make sure that everything was running smoothly, also calculate a new trajectory for that shuttle to go around the moon and then get back home safely. And they did it. And they did it with the help of a couple people from the back room. So they would often coordinate with other folks as they saw anomalies. They did it with a couple of people from there, and they actually used materials to prototype. They used materials that they would have had on the shuttle itself. And so then they were able to solve the immediate problem they saw, and then communicate that solution back up to the shuttle. And then the astronauts, Jim Lovell and Jack Swigert, would actually be able to implement that. So, next is the back room itself. So I mentioned the flight controllers, and the flight controllers are really responsible for looking at tons of data. They're looking at all of the data that's coming off of that IBM 790 mainframe. So these flight controllers is kind of a little bit too much for them to handle. They would actually go through simulations all the time, and the sim guys, as they call it, the guys responsible for putting these simulations together, they would actually try to throw all of the flight controllers off. So sometimes they knew what was coming and they could make split-second decisions. Sometimes they didn't. And when they didn't, they would use the mathematicians and the scientists from the back room to help them coordinate. And so it was a very close relationship between these two different entities. And that relationship, really, it was never adversarial. It was extremely dedicated. And to this day, Cy, as they call him, Cy used to work ecom during this time. He actually notes how trusting that relationship is. If something happened on one end, the other side took blame. If somebody was excited about something on one end, the other side made sure that credit was paid where it was due. So that relationship was super rock solid. And then the flight director. So the flight director was the CEO of the entire mission. They were responsible for everything that happened in the mission and the safety of the astronauts and the success of that mission itself. And they actually the flight director has a chair right in the middle of all of the action on the Mocher floor. They would sit in that chair, and it actually had aisles on either side, so it got nicknamed the throne. Even though they were up and running around and helping out their crew, they were known as sitting on the throne. So, this thing keeps scrolling on my keynote and actually not going forward. Okay, so let's talk about what just happened? There we go. Okay, sorry about that. Let's talk about the console itself. So the console, it looks pretty smart. It has a lot of buttons on it, but it was actually pretty dumb. It really just translated what was happening on the mainframe. So all of the information that was coming off of the shuttle, all of the information that was coming around the shuttle as well, the information for the vitals and the statistics of the astronauts, and also the mission itself. So how everybody at Mission Control was communicating, all of that information was being sent to the flight controllers who were manning these consoles. And so their job was really, when they saw an anomaly or something that kind of looked a little bit fishy, sometimes, like I said earlier, they would be able to recognize what that was and make a split-second decision on a recommendation. Sometimes they wouldn't. So they would work with everybody to come up with a recommendation to send back up to the astronauts. So what that looked like was this diagram. So at the bottom of the diagram, you see the communication that was coming off of the rocket. And so there are several points that are denoting where all of that information is being sent to Mission Control. When an anomaly is found, that team of flight controllers working with the back room, et cetera, they work together to come up with a solution. And so what this is called is air-to-ground communication. They're taking in all of the information they can to make sure that everybody is safe. And then what happens is they come up with a recommendation. That recommendation is approved by others who are very well trained in what's happening, and then they take that recommendation to the flight director sitting in that throne. And the flight director is the only one in that room who can actually communicate that information back up to the shuttle. And that's called ground-to-air communication. And then it gets communicated back up to the shuttle. They maintain a single point of contact. The astronauts don't have to deal with all of the commotion in the mission control room. So to me, this sounds pretty familiar. And so what you're looking at now is actually at GitHub, how communication happens on the GitHub platform itself. And so this is a typical branch and merge interaction happening. We have a project that got started. An issue was created. There was a problem that somebody noticed. And so they created an issue. And then the team or team of developers comes together and figures out that issue, solves it. And then they work on a resolution. They agree that that resolution is the best one or the one that they want to implement and put it back into master, and then they merge it back into the master branch. And so we're constantly maintaining that single line of communication all the way through getting your software shipped. So now we're going to launch this rocket. So this rocket, I'm actually going to, I think we're going to switch over to play a video because for some reason I cannot get internet, so I'm defaulting to a video of this. But I did put this demo together probably about an hour ago. So what we have here is I'm running this demo application that I've been working on with Gene Krantz, and I've got this rocket down here that we actually want to, let's say we're going to Mars. And so I've deployed this to my, to using GitHub pages. And so you see that GitHub pages URL there, and it's actually referencing the repo name. The repo name is Mission Control. And if you're curious about what's going on, you can check it out too. Okay, so we're gonna go check out this repo. Don't pay attention to my, this is the profile of a product manager, so I don't do a lot of coding anymore. But I'm gonna use the jump to. This is a new feature from GitHub to help people search. I'm gonna use it to jump to that mission control repo. So here's the repo. GitHub, pretty familiar to folks. I can put some README in there, and it looks like I've got some issues. So somebody's identified some issues on my team, and it's actually Gene Krantz. He's so good at his job. He identified that we have some issues here, so I'm gonna go and check out that first issue. So he's got, the GPL logo is on the shuttle, and this is issue number 40. We'll have to remember that later. So he says, it looks like the GPL logo made it to the shuttle. Let's look what that is. So the GPL logo is at the bottom. This should actually say NASA. So I'm just going to comment really fast, and I'm gonna let Gene know that I know it, I'm here for him and that I know what he's talking about. I'm gonna @mention him using autocomplete, and then I'm gonna comment, and he'll get a notification so that he'll know that I'm on it. So I'm gonna come back over to the code, and I'm gonna go and fix this. So I know where this is. It's in the main.css file. So I open that up, and I'm just gonna, it's a small change. I'm just gonna use the GitHub in-browser editor, and I'm gonna go change that CSS variable, scroll to the bottom, commit my changes. I tried to give it a funny name, but it was hard. And I'll say I'm updating these logos, give it kind of a good description. I wasn't so happy with this description, so I ended up changing it halfway through. But I'm gonna say this fixes, and then I'm gonna reference that issue number. It fixes number 40, and you'll see why that's important later on. And so I'm actually gonna change this to make sure that he knows exactly what I'm doing. And I'm gonna create a new branch. And I know that there were 3 issues in there, so there are probably some things that I'm going to want to apply to this branch as well. So here I am creating my pull request. Since Gene's on my team, I'm actually going to assign him as a reviewer. And then I'm gonna create this pull request. So pull request is created. You'll see that automatically GitHub notices that I've said fixes and an issue number. And so it actually applies that issue number and turns it into a URL. And it'll do something magical when we merge all this stuff back in. So let's check out this next one. So there's no fuel in the tank. This is also from Gene Krantz. So he says that we're not gonna be able to launch this rocket if there's no fuel in the tank. So I'm going to go put some fuel in the tank. I'm walking through a similar workflow that I just did to let him know, give it a description, let him know what's going on. I mentioned him using the autocomplete. He's on my team, so we know who he is. And then I create comment on that issue. Now I'm going to go, remember I made a branch? I'm gonna go back to that exact same branch, prepare for takeoff, and I'm going to make my edits here. So I go into the main.css style sheet, and I'm going to edit this within the browser itself, and I'm gonna update that CSS variable to 1. I'm gonna put 1 tank of gas in, and I scroll down to the bottom, give my commit a name, give it a short description, and then I reference that issue number. And apparently I'm a very slow typer. So I'm just going to commit this to that prepare for takeoff master branch. And then I'm gonna go, actually there was one more issue, so I'm gonna go check this one out. This one was from Neil Armstrong, who just kind of dive bombs into my project sometimes. He says that CSS variables aren't supported in IE, and he gives me a little bit of a reference. Since we're just launching this at the conference today, I don't think we have to pay attention to CSS variables and being available in IE. So I'm actually going to say this isn't mission critical. We don't have to support IE. I'm a Mac user, so I'll bleed for that. So I reference him so he knows that we're prioritizing this a little bit later on. And then I'm going to show you what happens on Gene Krantz's screen. So now we're looking at Gene Krantz. So Gene Krantz and I don't live in the same place. So we're looking at his screen, and I'm actually showing you the recent activity on his dashboard. I refresh that screen, and you can see that he's got the pull request review that I just assigned to him, and he can see that somebody's commented on those issues. So when he clicks into it, he can see automatically that I'm referencing that issue, and that's why he's getting those. And then also he can see that he needs to do a pull request review. So he clicks into that, he goes and does his review. Now he can choose to add a comment, a line comment, or a comment about the entire pull request. But what he's doing, he kind of looks things over and he's like, yeah, okay, this looks good. So he approves it for launch. He's going to comment and approve this pull request at the same time and submits it for review. So then back over on my screen, and when I go over to that pull request, I can actually see that it's approved. So clicking into it, what I'm going to do next is merge that into the main line. And every time, when I'm using GitHub Pages, every time something is merged to master, it'll actually do a deploy of pages for me. So I'm saying that we're going to ship this. I give it a little rocket. That pull request is successfully merged and closed. And I'm just going to show you what happens on the issues when these references are in place. So when I click over to issues, you'll notice that GitHub automatically closed those issues because that PR that referenced them was merged into master. So then if we go over to my rocket, you'll see that it's kind of still on the ground. I've got to give it a little refresh of the screen. And now we have liftoff. So I've added the fuel, and I've changed, you can see that I've changed that logo, and it all got deployed automatically through GitHub Pages. So I refreshed it one more time. Okay, so that is the demo, and I have to ask the guys backstage to switch back to my computer. Okay, so that is the demo of mission control, and you can check it out, Simsoka/mission control if you want. It's a pretty simple demo, as you saw. But so I know that that's how a lot of collaboration happens on GitHub, and that was a pretty typical flow for a branch and merge. A lot of collaboration and communication happens outside of github.com. It happens in person, it happens on Slack, and it happens all over and around your team. So what I did a couple weeks ago, what I did when I was back in San Francisco was I actually went to a couple of the engineering managers and engineering directors there, and I asked them what their top tips are for working with their team for collaboration. And they gave me a whole long list, and it was way too much for me to be able to talk with you all about today. But I chose the top 6, and so I'm going to go through them. The first one is really investing in those interpersonal and those empathetic relationships that you're trying to cultivate on your team. You're trying to cultivate a culture of trust. And so really investing in how you're going to do that and how you're going to build that environment on your team is important. This happens through stand-ups. It happens, if you're a remote culture like GitHub is, it happens through daily meetings, through weekly meetings. It also happens on Slack, etc. And what we really like to do is get the teams together once or twice a year in person. I think when I was, before GitHub, I actually worked at Heroku. And both companies are very remote. And this was at Heroku, that was my first experience with a remote team. And I remember, I think I went a whole year before I realized that I was the shortest person on the team because I had never, my entire team was remote. I had never met them in person. So while we did have some styles of working together, after I actually got to meet them in person, we developed this trust that really united us, and we were able to ship some pretty amazing software. The next one is, you heard about design sprints earlier today, which I thought was super cool. And one of the top things on our director of engineering for what we call experience engineering, he said you should invest in as many design sprints as you can as a team. So on my team, I know that everybody comes from different disciplines. I've got product managers on my team, product designers, I've got engineers, I have people who are outside of that delivery team themselves in marketing and sales, et cetera. But everybody on that team, no matter who you are or what your discipline is, you are a maker, and we're all making this software together, and we're all responsible for shipping it. And so I really like to pull people into the creative process of actually making that software. And it can be from API design to UI design to looking at a crit, et cetera. And so it's really important for us to spend some time together and actually bake in that time into the project plan itself. And so pair programming, sometimes this is a no-brainer, but it is super important for some teams, especially remote teams, to pair program together. And this doesn't, some teams actually will schedule their pair programming. Some teams do it a little bit more serendipitously, like after a stand-up, you pair for a little while. And what this does for folks on the team is it really speeds up that knowledge transfer. And so you don't want, if one person on your team goes on vacation and that's the only person that knows about your notification system, you can't fix bugs for your notification system while they're on vacation. And so we want to have that knowledge transfer between those teams, so it really helps with that. It also creates a fluid exchange of individual workflows. So as I'm looking at somebody else's screen, I might notice that they use a different keystroke than I do, that if I applied that to my workflow, it might make my workflow a little bit faster, or may like their Vim setup or something. And so it gives me some creative ideas for how to improve my own workflow. Or why their workflow might impede my workflow in a certain way. We can have a conversation about that. And then it just builds this organic conversation between two different people, usually engineers, who are working on hard problems. It allows them to have a kind of a more private, intimate space where they can vent about things, or they can kind of geek out a little bit more, and they can share information and things with each other. And on that vein, it's really critical to always be thinking about feedback. And so at GitHub, I help run product management with my counterpart. His name is Remus Silkaitis. So we have two people running product management. I run one arm of the business, which is developer experience. He runs platform services, and so it's kind of like a front-end, back-end exchange. And we started at GitHub actually at the same time, and we knew that when we started, we were going to have this crazy trust between each other because we were running this team together. And so we are constantly giving each other feedback. And when we give each other feedback, we're constantly taking it. And so I think I've known Remus and worked with him for probably about 3 years. And again, because of this, I've been able to become a much better collaborator and a much better employee at my current company because we constantly talk about feedback. So the next one, at GitHub, when we set out for planning our whole entire year, the executive team defines OKRs, that's objectives and key results. They define it from the executive level, and then based on their OKRs, their direct reports, people that report into them, write their OKRs, their objectives and key results. And then it goes down another level, their direct reports write theirs. And so all of these OKRs, all of these objectives cascade all the way down to the project level, to the team actually executing against these. And so what happens is that you are actually able to, as you plan projects week over week throughout the year, you're actually able to make sure that those projects tie all the way back up to the executive level. And so if you're an IC working on something and you don't know whether or not it's going to hit the bottom line or contribute to the bottom line, you know it is because all of those projects cascade all the way back up to what our leadership team has set out to do for the year. And so that's super important to stay coordinated. And then the last one, one of the questions that I ask new product managers when they come to interview with me is consensus a good thing? And what I'm looking for is, I don't want them to say yes or no. What I'm looking for is how they actually navigate a very difficult conversation. If you can imagine it, we have difficult conversations at GitHub all the time. because we're shipping hard software. And so if you're shipping software, you're going to have difficult conversations. You're going to disagree with each other. And it's really important to be able to either discuss until you agree. I recommend if you're going to do that, put a time box on it so that you don't keep spinning and then you actually end up never shipping the thing. Or you can disagree, but agree to commit. And then you can agree on a path forward. And that's what's going to preserve your momentum. So what this all boils down to is that communication needs a structure that's super intentional. And that's what really GitHub gives you. It gives us the tools for delivering vital products and going from good products that we're shipping to world-class products. And that means we're never going to miss, or we're going to minimize missing important questions and important decisions. So I'm going to have the guys backstage play another video for you. What this is I want to show you the kind of culmination of what all this stuff comes together and what it feels like to collaborate really well on a project. And so what you're looking at here, and I don't know when they're switching over. You guys got it? I'll let them fiddle back there. I'll tell you more about what's happening in this photo. What you're looking at here is what mission control looks like today. And this is actually the Curiosity rover team as they were landing the Curiosity rover on Mars. Curiosity rover is a rover the size of a car, and it's really important that we actually landed that on Mars because it's able to take in a lot more information and send a lot more information back to Earth about what's happening on Mars. And this means that eventually, with all of this information, all this data, we're going to be able to put humans on Mars. So I think I'm just going to play this myself here. Sorry, we're having technical difficulties. I'm going to see if this works. There we go. So they've hit Mars's atmosphere. They're getting excited. And there it is. This goes on for a while. This video always kind of gives me chills. But the rover is now on Mars. It continues because the rover, it's not over yet. And this mission control, they've been working for years to be able to actually pull this off. So you can imagine their excitement. Some people are crying. Here comes another one. We've got images coming back from Mars now. So the celebration continues. It's pretty amazing, and I encourage you to read about it if you want to. And so that's what it looks like when a team like this. That's what it looks like when a team like this pulls something off really seamlessly. And you'll notice in this, I just want to point this out really fast. In this photo and in that video you saw, and in a lot of the photos that I've been showing at Mission Control, you saw that everybody was wearing the same thing. Everybody's wearing either, back in the 60s it was a white button-down short-sleeve t-shirt, but now it's this blue NASA shirt. It's a little bit uniform, but it's also, if you notice, no matter who you are, there's some people who are more senior, some people who are more junior in the room. No matter who you are, everyone wears the same shirt. And that's part of the NASA One philosophy. They have a strong philosophy that their team is we and not I. So they really collaborate, and they put they instill that sense of trust in the team by talking about the team itself instead of talking about the individuals of that team. So a successful release, really what you just saw is it's the sum of all of these parts. It's about collaboration, and it's about communication, and what pulls all of this together. And for NASA, what seemed like a really insurmountable task back in 1969, and then again back in 2014, what seemed like that insurmountable task, they were actually able to pull it off, and that's because of these sophisticated collaboration and communication protocols that they had. And I know that shipping software isn't rocket science, but we're not sending shuttles in the moon in a vacuum. And we really need to collaborate on that. We really need that collaborative environment to be able to pull something like this off. And I'm really excited to be able to, I was excited to be able to geek out and learn a little bit more about NASA that I hadn't learned before reading about the mission control teams. But I'm really excited to be able to bring that to you, and hopefully you're able to take some of this away and apply it to how you communicate with your own teams. So with that, thank you so much, and please enjoy the rest of the conference. Come find me. I'll be around after this, and then I'll be around tonight as well. Come find me if you have questions about any of this, about any of the work that we're doing at GitHub regarding developer experience. And yes, we are hiring. Yes, we are 60 to 70% remote. So please contact me, look me up. I'm Simsoka on Twitter and GitHub, and that's my email address. So please come find me, come talk to me about all of these things that are super exciting to me. I'd love to share more. Thank you.